स्टार्ट करो बेटा। नमस्कार दोस्तों, वॉइस कंफर्मेशन कर दीजिए बेटा, आवाज क्लियर है? तो आज का लेक्चर है मेजरमेंट्स का, लेक्चर नंबर 5। CRO, क्यू मीटर, DVM। गुड मॉर्निंग, गुड मॉर्निंग नीलेश। ये लास्ट क्लास में हमने डिस्कस किया है, आज हम डिस्कस करेंगे CRO, क्यू मीटर, DVM and the gate PYQs in short. Okay. So please make a note of this diagram. This diagram. Chalo, my dear, have you noted the diagram? Yeah, please note on the diagram. Good morning, Nilesh. Complete it. Taken? तो जितने लोग लाइव में देख रहे हैं एक बार आपका कंफर्मेशन कर दीजिए बेटा। कहाँ से हो आप, क्या सब्जेक्ट पढ़ रहे हैं, आर यू फ्रॉम ट्रिपल ई और व्हाट? दिस इज द लास्ट लेक्चर इन अवर गेट क्रैश कोर्स। ओके, सी कैथोड रे ऑसिलोस्कोप के ऊपर हमको बेसिकल क्वेश्चंस आ रहा है, बेसिक क्वेश्चंस आ रहा है, बेसिक क्वेश्चंस लाइक फेज मेजरमेंट, फ्रीक्वेंसी मेजरमेंट, इसके ऊपर क्वेश्चंस आ रहे हैं। ओके, चलो माय डियर, so if you see the diagram of cathode ray oscilloscope, so this is a functional block diagram of, this is a functional block diagram of CRO. So in the functional block diagram of CRO we are having certain components. So first comes the electron gun assembly. So this is the electron gun assembly. So in this we are having a heater. So this heater is going to be heated, so the electrons are going to be emitted out. So this heater works on the process called thermionic emission. The heater emits the electron on the process called thermionic emission. So because of the heating the electrons are going to be emitted, that's why it is called thermionic emission. Because of the heating the electrons are going to be emitted, that's why it is called as thermionic emission. So these electrons are coming out and these electrons are passing through a set of anodes. So these are called, this is the first one, this is called pre-accelerating anode, and the second one is called focusing anode, and the last one is called accelerating anode. Okay, so these are the three sets of anodes. So the pre-accelerating anode and accelerating anode both are maintained at the same potential, but focusing anode is maintained at the lesser potential, so that electrons are going to be focused. And after this set it is moving to a vertical deflection plates. For the vertical deflection plates you are going to give our test signal. जो कुछ सिग्नल्स आपने मेजरमेंट करना चाहते हो, जो कुछ सिग्नल का आपका एम्पलीट्यूड, वोल्टेज, करंट, फ्रीक्वेंसी मेजरमेंट करना चाहते हो, तो वो सिग्नल आपने वर्टिकल डिफ्लेक्शन प्लेट्स को दे रहे हैं। इसके बाद आ रहे हैं हॉरिजॉन्टल डिफ्लेक्शन प्लेट्स। हॉरिजॉन्टल डिफ्लेक्शन प्लेट्स के लिए आपने हॉरिजॉन्टल सिग्नल देते हैं, टाइम बेस्ड सिग्नल देते हैं। जनरली आप कोई ना कोई समय आप हॉरिजॉन्टल डिफ्लेक्शन प्लेट्स को, वर्टिकल डिफ्लेक्शन प्लेट्स को जो कुछ सिग्नल दिया है वही सिग्नल भी दे सकते అనిషా టైం వేస్ట్ చేస్తున్నావు తెలుసా నిజంగా. Taken, dear? Taken? Yeah. Please take that V. Okay. थर्मियोनिक एमिशंस के अनुसार इलेक्ट्रॉन्स को आते हैं, इलेक्ट्रॉन्स आने के बाद हमको सेट ऑफ एनोड्स यूज कर रहे हैं. सो इफ यू सी दिस, द बेसिक फंक्शनैलिटी, व्हाट आर द ब्लॉक्स वी आर हैविंग? वी आर हैविंग द कैथोड रे ट्यूब, एंड इसके बाद इलेक्ट्रॉनिक गन असेंबली है. उसके बाद डिफ्लेक्शन प्लेट्स है. डिफ्लेक्शन प्लेट्स में हमको दो सेट्स रहता है, एक वर्टिकल डिफ्लेक्शन प्लेट्स, एक हॉरिजॉन्टल डिफ्लेक्शन प्लेट. ओके, तो दो सेट्स ऑफ द प्लेट्स रहता है, को वर्टिकल डिफ्लेक्शन प्लेट्स बोलते हैं. वर्टिकल डिफ्लेक्शन प्लेट्स, और एक है हॉरिजॉन्टल डिफ्लेक्शन प्लेट्स. वर्टिकल डिफ्लेक्शन प्लेट्स एंड हॉरिजॉन्टल डिफ्लेक्शन प्लेट्स. So now if you see this particular thing, how the deflection happens. Okay, how the deflection happens. So once this particular electron enters into the deflection plates, according to accelerating voltage, so the finally it is coming with an accelerating voltage now. So this is the accelerating voltage. So a accelerating voltage say electron is entering into the deflection plates. Once it comes into the deflection plates, from the center of the deflection plates it is going to get deflection. So here there are certain parameters. So this is the length of the deflection plates, LD, and this is the distance between the deflection plates, D, and this ED is the potential that is applied to the deflection plates, and EA is the accelerating voltage. Okay, and the electrons comes from this center and it gets deflection, and at a distance of L from the center of this deflection plates to the main screen, so there is a distance L. So in this distance there is a deflection is going to happen. Okay, so the deflection, if you see, this deflection is the D, capital D. So once again I'm repeating the parameters. Small ld is the length of the deflection plates, small d is the distance between the deflection plates, EA is the accelerating anode voltage by which the electron enters into the deflection plates, ED is the voltage that is applied to the deflection plates. ये voltage कहाँ से आ रहा है? ये voltage आपका test signals का आ रहा है. So test signal voltage, this test signal voltage is given to the op amp, operational amplifier. Operational amplifier से जो कुछ voltage आ रहा है, so that voltage is given to this. So this is our ED. So this is our voltage. Okay, so this ED is nothing but beta times of V test signal. Remember this point. Okay, next, then it deflects the center distance, the distance from the center of this deflection plates to this main screen, that is a capital L, and this total is the from the center of the screen to the top maximum, that is a capital D. So what is the deflection formula? Okay, so the deflection is given by, once again I want to give you the parameters list. So these are the information for your voltages. Okay, so this is the EA, my dear. So this is what we call as EA, voltage of pre-accelerating anode volts. Small e is a charge of an electron in coulombs, that will be 1.6 into 10 power minus 19. That is 1.6 into 10 power minus in coulombs. M is the mass of electron, that is 9.1 into 10 to the power minus 31 kg. VOX is the velocity of the electron when electron entering the deflection plates in meter per second. ED is a potential between the deflecting plates. Small d is the distance between the deflecting plates in the meter. LD is the length of the deflection plates. This is a small LD. Small LD. and capital L is the distance to the screen and the mid of the deflection plates. Capital D is a deflection of the electron beam on the screen in the y direction. Okay. So these all are the major things. Now वहाँ से आपको deflection का formula निकाल सकते हैं. So deflection is given by formula. So deflection D. Okay. Deflection D is given by formula as LLD to DE. Okay. The units are in centimeters or meters. Next, sensitivity, deflection sensitivity को हम क्या बोलते हैं? Deflection sensitivity. We take the sensitivity. Sensitivity is given by S. So that S is nothing but deflection output by deflection by applied voltage deflection. So I can take this as D by ED. Output is deflection, input is the deflection plate's voltage D by ED. So then the formula will be LLD by 2D into. Next, deflection factor. There is one more parameter called deflection factor. Deflection factor is equal to G. G I can take it as 1 by S. So here the units are centimeter per volt. When I take 1 by S, that will be 2D EA by LLD. So then the units are volt per centimeter. Okay, please make a note of these points. जितने लोग लाइव में देख रहे हैं मुझे बेटा एक बार कंफर्मेशन कर दीजिए जो आप आर एबल टू सी इट और नॉट, आर एबल टू राइट इट और नॉट. Shreshth. Noted? Okay. So after this, we'll go for the questions now. We'll open a question. Yeah. See these questions, my dear. Okay. I will give you that question list later. So let us just make a note of these points. I will discuss the questions list later. So first, let me talk about this part, working procedure. So if you see the mode of CRO, how the CRO can work. CRO can work in two modes. One is a YT mode, other one is a XY mode. In YT mode, what happens? In YT mode, what happens? What we are going to apply to the horizontal deflection plates, and if you see this YT mode, in YT mode, for the vertical deflection plates and for the horizontal deflection plates, if you check, so for the vertical deflection plates, we are giving the test signal. So this is a Vy with respect to time. So this is a test signal. Yes. For the horizontal deflection plates, we are going to give the time-based signal. We are going to give the time-based signal. That is a time-based signal. This is what we call as time-based signal. So now, as a result, what is going to come output? As a result, what we are going to see on the output, we are going to see the Vy with respect to x-axis. What we are going to see. So we can measure its this is a signal. So what we can measure here, we can measure the amplitude RMS value. So we can measure this peak value. So what are the parameters to be measured? What we can measure? We can measure the peak value. We can measure the average value. We can measure the peak to peak value. We can measure the RMS value. So these are the measurements that we can do in the YT mode. Okay, these are the measurements that we can do in the YT mode. Have you taken it? Let us go for the XY mode. In XY mode, for both the plates, we are going to apply the different signals. Suppose if I am taking this the vertical deflection plate, this is a horizontal deflection plate. So this is a VDP and this is the HTP, horizontal deflection plates. So here what we are going to apply for the vertical deflection plates, what we are going to apply for the horizontal deflection plates. For vertical deflection plates, I am applying the sinusoidal signal. This is a Vy. For the horizontal deflection plate also I am applying the sinusoidal signal. But the point here is the sinusoidal signal may be having some phase difference, or it may be having some frequency difference also. It may be having some double frequency, some frequency shift may be there. Okay, so as a result, we are going to get certain Lich patterns here. So either we are going to get a Lich patterns like this. We are going to get the Lich patterns. Either we are going to get a straight line, or we are going to get a straight line, or we are going to get a ellipse, or we are going to get a circle. Okay, like this. So these are the different possibilities, different patterns as per the phase shift or frequency shift. So these patterns को हम बोलते हैं Lich pattern बोलते हैं. क्या बोलते हैं हमको उसको? Lich patterns. So from the XY mode, what we can measure? So from XY mode, the parameters to be measured, the parameters that we can measure from the XY mode: phase, frequency, we can measure, especially the phase shift and the frequency that we are going to measure. That means the relation between the frequency along the Y plates to the frequency along the X plates, like that. Okay, so let us see certain patterns now. Right, we will understand the patterns and we'll see here. So this is the phase angle difference. I've given a collection. Okay. Good morning, Ninja. Good morning. Good morning. Are you able to understand? So now we will start the Lich pattern. एक बार आप see here, the phase difference is between the, that means the vertical deflection plates. Suppose if I am applying the vertical deflection plates, Vy, that is vertical deflection plate, is Vm sin omega t, and for the horizontal deflection plate also we are applying the sin omega. दोनों के बीच में phase difference 0 degrees है, then we are going to get a straight line. So that how it comes, that is a derivation, that part we can see. The straight line comes in the first quadrant and the third quadrant. First quadrant and the third quadrant. Okay. Are you following? Yes, morning. Chalo. Now let us move for the next pattern. Suppose it is less than 90. So if the phase shift angle is less than 90, that means the phi is the Vy and the Vx. If you check, okay, this is Vm sin omega t, so this is Vx is Vm sin omega t, Vy is suppose V sin omega t plus phi. This phi is greater than 0 but less than 90. Okay, in that case we are going to get an ellipse in the first quadrant and in the third quadrant, and it is a clockwise ellipse. Clockwise. Please remember these points. Please make a note of these points. Okay. Chalo. In a similar way we can go for the others also. This is for 30, 330, and next this is for 45 and 315. So this is also ellipse. In which quadrant we are getting? In the quadrants of first and second, getting the ellipse. Next 60 and 300 we are going to get ellipse. 60 and 300 also we are going to get the ellipse, but 90 degrees if we check, for 90 degrees and 270 degrees we are getting the circle. For 90 degrees and 270 degrees we are getting the circle. For 90 we are getting the clockwise. For 270 we are going to get the anti-clockwise. Okay, so for when the phase shift, that means what? If I am taking the Vy and Vx, Vx is equal to Vm sin omega t, and this is Vy is Vm cos omega t, or this is Vm sin omega t plus 90. In that scenario, get this ellipse, this circle, clockwise for 90, anti-clockwise for 270. Okay, that is the thing. Suppose once it crosses the 90 now, then we are going to get again ellipse, but this time the ellipse is going to come as clockwise ellipse only, as long as less than 90 degrees, but in the quadrants second and fourth. In which quadrants it is going to get? In the quadrant second and fourth. Second and fourth. So this is about the ellipse. So less than 180 it will be in the clockwise only. So again this is also ellipse at 150 and 210, which is coming in the quadrants second and fourth. Second and next, इसके बाद we are going to get 180 degrees. For 180 degrees we are going to get a straight line, so which is in the second and fourth quadrants. Second and fourth quadrants we are going to get a straight line at 180 degrees. So from 180 degrees onwards the cycle changes, it is going to become as anti-clock. Okay, so above 180 if we check, you are going to get the different patterns. Now this is all about the Lissajous patterns. So listen, when both pairs of the deflection plates, whether it is a horizontal deflection plates or the vertical deflection plates of CRO connected to two sinusoidal voltages, the pattern appear at CRO screen are called as Lee-Sage's pattern. So whether it is a phase shift related or frequency shift related. Okay, so now see here, I am going for the frequency. Similarly, there is a possibility of frequency. For example, the Vy and the Vx, if you check, so there may be a different frequencies but having the same phase, sin omega 1t, and this will be sin omega 2t. So it is running with a frequency f2, it is running with a frequency f1. So then what is the concept here? So then you are going to get a pattern. For that pattern we have to apply certain intersection points or horizontal points. So frequency applied to the y-axis to the frequency applied to the x-axis is given by number of horizontal tangencies by number of vertical tangencies. Either you can take this or you can take this. Number of intersections of the Lee-Sage's pattern with the horizontal line to the number of intersections the Lee-Sage's pattern with the vertical line. Okay, so please make a note of this. And with this we are going for a picture. So try to answer this. What can be the answer for this? Try to answer this. What is the answer for this? What is the answer for this? What can be the answer for this? So if you want to know the answer, I can go like this: Fy by Fx. Is number of horizontal tangencies by number of vertical tangencies. We apply horizontal tangencies here. This is 2. This is also 2. So this is 1, 2, 3, 4. Divided by number of vertical tangencies. This is 1. This is 2. Perfectly closed. 1 and 2. The answer will be 2:1. Okay. So this is the one method. This is one method. The other method here is taking the intersection points. Actually, this is the picture, right? Okay, this is the picture. Taking the intersections point means the intersection line I can draw like this. I should draw the intersection line in such a way it should not pass through any common point. So what I can write here, Fy by Fx is intersections points here 1, 2, 3, 4, and this is 2. So anyway, the answer is same. 1. In both the cases, the answer is matching. Okay. So this is the technique you have to follow. Just follow the technique. Whether you are comfortable with the drawing the tangencies or drawing the intersections, accordingly you can go through. Let us go for the next picture. See this picture. Just try to answer me. This is not a complete picture. This is an incomplete pattern. So if the incomplete pattern is given like this, then what to do? See here, if you apply the tangencies concept, so this is the fully touching concept and this is not half. So this tangency is not completely touching, right or not? So this is half and this is the full, and this is the full and this is the half. So if you apply the formula Fy by Fx, Fy by Fx is equal to number of horizontal tangencies by number of vertical tangencies. Here the number of horizontal tangencies, this is 1 and this is half. This is 1 plus half. Niche also, this is 1 and this is half. 1 plus. And the vertical, if you check, the vertical if you check, okay, tangencies, check, it can be half and half, right? It cannot be full anywhere. So if you check this vertical, it will be 1 by 2 plus 1 by 2. So suppose if you are getting any confusion in this method, I suggest you go for intersection method. You go for intersection method. So, see here, frequency applied to the y, the frequency applied to the x-axis, number of horizontal intersections points divided by number of vertical intersection points. If you take this picture now, horizontal intersection points are how many? 1, 2, 3. Vertical is only 1. 3 by 1. Same thing is coming here. 3 by 1. 1 plus 1, 2 plus half of 3 plus 1. So here this is half, and this is also half. Understood? That's why. Whichever the method you are comfortable, you can go through it. Yes, Shivdeep Kumar, good morning. Nice to see you. Have you followed my previous lecture, Shivdeep? Make it fast. Have you followed my previous lectures, Shivdeep? Yeah, try to answer this question now. Let us see this part. This is the picture. How to do this picture? Please tell me. What is the answer for this question? This is a Lysage's pattern. What is the answer for this question? Please tell me. Try to answer this question. What is the answer for this question? Yeah, you see here, there are two methods. If you take the tangencies method, draw a tangent here, horizontally touching 3, okay, and vertically touching 2, vertically touching 2. Fy by fx is equal to number of horizontal tangencies by number of vertical tangencies. So horizontal tangencies are how many? 1 plus 2 plus 3 plus 4 5 6, and vertical 1 2 plus 4. So 3 by 2 आना चाहिए in this method. Or if you take the intersection points method, if you go through the intersections points, okay, in this method 3/2, or if you go with the intersection point method also it is okay. If you go with intersection points, how to go with intersection points? How to go with intersection point? See here, draw an intersecting line such a way it should not pass through the common points. Go like this. You cannot draw between the common points, okay? And you can draw a intersection line vertically like this, okay? So Fy by Fx, number of horizontal intersection points and number of vertical intersection points. The horizontal intersection points 1, 2, 3, 4, 5, 6. Vertical intersection points 1, 2, 3, 4. So then also the answer is 2. 3/2. Matching or not? Yes, what is the doubt? Siddiq, what is the doubt? What is the doubt? Followed? Which subject? Measurements? Is it measurements related? Yes. Which measurements related? What is the doubt you ask me? Don't ask me general doubts. Subject related doubts you ask me. Chalo, try to answer this question, my dear. Just a second. Yeah, try to answer this question. Please tell me the answer. Yes, what is your doubt, man? I can't solve simple AEGE or line questions. I have qualified GATE in 2021. Okay. So, AEGE you are not able to solve. Basically, क्या है ना, AEGE assist. So, what is your doubt? What should I do now? AEGE is basically fundamentally questions asked from the basics. It is not complicated like GATE exam. It is very diploma level. So they will ask some basic questions. So you have to study the basics very well. So for that you have to go to the diploma level textbooks. Okay. So there are certain authors, great authors. So those textbooks you have to study, or you can get the diploma level, polytechnic level notes, and that notes will be enough. They won't ask you much numerical question. They will ask you the fundamental questions, conceptual questions. तो उसके लिए आप नोट्स लिखना पड़ेगा, और कोई AEGE का क्लासेस आप ज्वाइन कर सकते हैं ना. हमारा इंजीनियर्स वाला प्लेटफॉर्म है ना, इंजीनियर्स वाला प्लेटफॉर्म पर आपको AEGE का कोचिंग भी आ रहा है उधर. तो SSC JEE का क्वेश्चंस, बेसिक क्वेश्चंस पूछ रहे हैं उधर. इट इज नॉट एज मच कॉम्प्लिकेटेड एज गेट, बट इट इज थोड़ा लेस कॉम्प्लिकेटेड है. लेकिन उधर देखो अभी CRO के ऊपर थियोरेटिकल क्वेश्चन पूछता है उधर. हमने गेट में CRO का कंस्ट्रक्शन के बारे में इतना फोकस नहीं करते, लेकिन अगर आपने SSC JEE AEGE को गए तो CRO का कंस्ट्रक्शन में व्हाट इज दैट थर्मियोनिक एमिशन, व्हाट इज दैट प्री एक्सेलरेटिंग एनोड, व्हाट इज दैट फ्लोरोसेंस, okay, what is the material, what is the concept behind the design of the secondary emission, ऐसा क्वेश्चंस पूछते हैं. तो उसके लिए आप थियोरेटिकली बहुत स्ट्रांग होना है. Oh, superb. So this is the problem. You have qualified ESC and GATE, but you have not qualified SSC JEE. Means I will tell you the reason. The reason number one is the people who are writing for SSC JEE, their main focus is only job. In GATE and ESC, the main focus is not job. The main focus is, in GATE especially, qualifying is different. but SSC JEE का qualifying, the calculation will be different based upon the number of aspirants and the number of posts. They will decide the qualifying mark. So here, my dear student, you have to go through all the subjects basic notes. Okay, you please follow it. The preparation for the GATE and the preparation for SSC JEE is completely different. That's why you could have observed. You could have observed in our GATE Wallah, and the faculties who are teaching the measurements and the persons who are teaching measurements in SSC JEE may not be same. Okay, so that preparation level you have to change, my dear. Okay, in depth basics पर ज़्यादा focus करना है, ज़्यादा numerical का content नहीं है. Okay, चलो answer this question. Change the preparation style, my dear. Change the preparation style. कोई AE JEE में success हो गया, Siddiq, I suggest you to take some guidance from the rankers or people who are successful in AE JEE. Okay, you may get some YouTube videos. What are the things they have followed? The person who is got AE JEE, he may have some interview, right? So in this, he will tell what are the things he has followed. Okay, don't worry, definitely you will be successful. I wish you all the best. Please continue your preparation. Okay, G. Please try to answer this question. I'm not getting the answers here. Every question I am only solving. What is the answer for this question? Please tell me. Yeah, just you have to change the preparation style, my dear. कोई wonder नहीं है, कुछ उसमें कोई secret ही नहीं है. There somewhere you are doing some mistake in the preparation. You just change the preparation style. Maintain short notes. Maintain each and every point you note down. That like that. What is the answer for this question? Siddiq, can you answer this question? Try to answer. What happened here? You are not answering, you are talking just general chatting, but you are not involved in the class. This is not the way. Even though it is a YouTube session, you must involve in the class. That's why faculty gets disrespected, disappointed by your response. अगर आप YouTube को आने के बाद जनरल चैट करने के लिए नहीं आते ना, इधर कुछ तो कुछ प्रॉब्लम सब्जेक्ट पर इन्वॉल्व होना है. ये सब्जेक्ट पर इन्वॉल्व करोगे. व्हाट इज द यूज ऑफ दिस लेक्चर ऑफ लाइव क्लास? then I can throw the guest lecture, recorded lecture, and I can keep it now in the YouTube. Once you are coming to the live class, means should give response. Response देना है. Response to answer. What is the answer for the question? Siddiq, please answer this question. I already told you how to answer this question. Number of horizontal tangencies by number of vertical tangencies. Very easy question. ऐसा questions आते हैं AE, JE में, GATE में. जितने लोग लाइव में हैं मुझे आंसर दीजिए भैया. अदरवाइज देयर इज नो यूज ऑफ टेकिंग दिस क्लासेस ऑफ यूट्यूब. इतना कंटेंट आपको फ्री में आ रहा है, कुछ तो कुछ रिस्पॉन्स देना पड़ेगा लाइव क्लास स्टूडेंट्स. यू हैव टू मेंटेन सम नोट्स एंड पेन एंड यू हैव टू गिव द आंसर, राइट? अदरवाइज इतना ब्यूटीफुल कंटेंट आपके लिए आ रहा है फ्री में. दिस इज ऑल द हाई लेवल कंटेंट which is collected from the different textbooks and different standard books and different previous examination papers. अगर क्या आंसर नहीं आ रहा है? I'm giving one more 30 seconds of time. I will expect the answer from you. Nobody is giving the answer. Waste. So we have to take the number of horizontal tangencies. 1 2 3 1 2 3 horizontal tangencies 3 हो गया. 1 2 3 1 3 plus 3 6. Next vertical tangencies. Vertical tangents, if you take 1 2 3 4 1 2 3 4. Okay, it's 4. Sorry. Here vertical tangents is, if you take 1 4 2 4 4 plus 4 8. Answer is 3 by 4. Am I right? So this is 6 by 8. If you take the 6 by 8, this is 3 by 4. Or if you go with the other method, intersections method, you see the intersection method, the intersection points, horizontal intersections, 1 2 3 4 5 6. So horizontal intersections, number of horizontal intersections by number of vertical intersections. Okay, horizontal intersections how many? 1 2 3 4 5 6. Vertical intersections, if you take 1 2 3 4 5 6 7 8. 3 by 4. In both the methods it is 3 by 4. In both the methods it is 3 by 4. Okay, so let us go for the next question. Yeah, try to answer this question. Answer this question. to answer this question? You are not giving the answer again. I'm expecting answer from you, but you are not giving the answer. See here. If you take the horizontal tangencies, this is completely full, this is half. Full, half. So if I am taking this fy by fx, number of horizontal tangencies by number of vertical tangencies. Horizontal tangencies 1, 1, half. 1 plus 1 plus half. ऊपर नीचे 1, 2. We'll take like this. 1 plus 1 plus half. 1 plus 1 plus half. So 2 and half plus 2 and half 5. 2 and half plus 2 and half 5. By vertical tangencies, these are vertical tangencies, completely 1 and half, 1 and half, 1 and half plus 1 and half. So this is 2 and half, 2 and half, 5. This is 3, 5 by 3. Or else if you go with intersection method, that's the best thing. Intersection method, let us see here. So this intersecting line, so I can take this is 1, this is 2, this is 3, this is 4, and this is 5. So number of intersections, if you take number of horizontal intersection points divided by number of vertical intersection points, if you take horizontal intersection points are 5, vertical, if you see, this is 1, 2, 3, so 5 by 3. Understood? That's it. 5 by. सर इंग्लिश की क्लास कब होगी? क्या इंग्लिश भैया? विच इंग्लिश? पीयूष, क्या इंग्लिश क्लास? मेजरमेंट्स आई एम यूजिंग बोथ हिंदी एंड इंग्लिश. इसमें प्रॉब्लम क्या है आपको? प्योर इंग्लिश प्योर हिंदी कहाँ भी नहीं मिलेगा. चलो बेटा, दिस इज ऑल अबाउट द CRO. लेट अस गो फॉर द नेक्स्ट टॉपिक, क्यू मीटर. सो व्हाट इज क्यू मीटर? क्यू मीटर इज यूज्ड टू मेजर द क्यू फैक्टर. क्यू मीटर से आपको क्या क्या मेजर कर सकते हैं? क्यू फैक्टर मेजर कर सकते हैं एंड इंडक्टेंस मेजरमेंट कर सकते हैं, डिस्ट्रीब्यूटेड कैपेसिटेंस ऑफ ए कॉइल. That means if you take a coil, what are the coil parameters? This coil will be having inductance, this coil will be having some resistance, this coil will be having some distributed capacitance. Okay, and the coil will be having the Q factor, and the coil will be having the resonant frequency. So these are the parameters we are going to use. So Q meter, the definition, the instrument which measures the storage factor or the quality factor of the electrical circuit. So if you take the Q factor of a coil, Q factor of a coil is nothing but omega L by R. How it came? Q factor is defined as voltage across the inductor by voltage across the resistor. So the voltage across inductor is I into XL and voltage across resistor is I into R. It becomes as omega L by R. अंडरस्टूड? क्लियर है? So this is a Q meter, circuit of the Q meter. The Q meter is used to measure the coil's parameters. So these are the coil. You see, these are coil. So these are coil parameters. Okay. So how it is going to happen? Okay. So before understanding this, you have to understand certain concept of resonance. If you see the resonance concept, so what is a resonance? So this is a resonance circuit. So resonance circuit RLC. So at resonance, what is going to happen? If you see this graph, in the RLC series circuit, when the circuit current is in phase with the applied voltage, the circuit is said to be in series resonance. Circuit current is in phase with applied voltage. That means the current and the voltage, the both are in phase. So when it can happen, this can happen only the inductive reactance is going to be cancelled with the capacitive reactance. Then only this can happen. Then the circuit is going to be purely resistive circuit. Then the circuit is purely resistive circuit. So when the circuit is purely resistive circuit, then what happens? The voltage and the current both are going to be in phase. So establishing the in phase relationship with current and voltage is the main agenda of the resonance. You have to understand this. रेजोनेंस बोलो तो वही है, रेजोनेंस बोलो तो कोई भी सर्किट हो, आरएलसी सर्किट में जो कुछ भी पैरामीटर्स हो एल एंड सी, मैंने क्या करना है, जो करंट ट्रैवल हो रहा है सर्किट में, वो करंट एंड द वोल्टेज बोथ शुड बी इन द सेम फेज. सो कैसे अप्लाई कर सकते हैं? वो अप्लाई करने के लिए हम फ्रीक्वेंसी को बढ़ना है. अगर आपने फ्रीक्वेंसी चेंज करते जा रहे, द इंडक्टिव रिएक्टेंस इंक्रीज होते जा रहे, कैपेसिटिव रिएक्टेंस कम होते जा रहे. एक्सएल इज इक्वल टू ओमेगा एल, एक्सएल इज इक्वल टू ओमेगा एल. अगर फ्रीक्वेंसी बढ़ते जा रहे, इंडक्टेंस भी इंडक्टिव रिएक्टेंस बढ़ते जाएगा. एक्सी इज इक्वल टू 1 बाई ओमेगा सी. अगर फ्रीक्वेंसी बढ़ते जा रहे तो एक्सी एक्सपोनेंशियल डीके हो जाएगा. सो एट एक्सएल इज इक्वल टू एक्सी, एट अ पर्टिकुलर पॉइंट क्या होगा? एक्सएल विल बिकम इक्वल टू एक्सी. सो सी हियर दिस अ पॉइंट. As the resonant frequency is increasing, the inductive reactance is increasing exponentially, and at the resonant frequency is increasing, Xc is decreasing. At a particular point called resonant frequency, there is a point. So this point is called XL is equal to Xc. Series resonance happens. Then what does it mean? At that moment, the inductive reactance and capacitive reactance both are going to be exactly cancelled to each other. Then the circuit becomes no inductive, no capacitance. In the circuit, only the resistance term will be there. So if you see the phasor diagram of this, we know that this is a current passing through the circuit, and the voltage across the inductor, that will be 90 degrees phase, that is the EL here, okay, and the voltage across the capacitor, that will be EC here, okay. So if you take the resultant component, this is the resultant and the resultant, so these both are equal phase diagram. So then the circuit becomes equal to resistive circuit. Okay. Actually, the voltage across the capacitor is what? I into Xc. But this I into Xc is equal to I into XL. Why? Because if you see this EC and this both are almost anti-phase to each other. So that's why I'm taking I omega L. So anything you can take. EC by E you can take. So EC by you take EC is the voltage across a capacitor. Voltage across a capacitor is equal to voltage across the inductor. So I into omega L, I into omega, I into R, omega L by R. That means what? At resonance, the voltage across the capacitor will be Q times of voltage across the resistor, the supply voltage. Okay, so that means this is the logic we are to use. So you apply a resonance to a circuit and you try to get the voltage across a capacitor. How to apply the resonance? Change the frequency. Go on changing the resonant frequency. Then what happens? The inductive reactance goes on changing and the capacitive reactance goes on changing. At a particular point, this inductive and capacitive reactance both are going to cancel. Then the circuit becomes purely resistive. When the circuit purely resistive, it draws the more current. So when the more current comes, then what happens? Obviously, the voltage across the capacitor will becomes maximum. So the voltage across the capacitor will be how many times of that applied voltage? Q times of the E. Okay, it becomes Q times of the E. So to know that, we are using the Q meter circuit. This is a Q meter circuit, my dear. Please make a note of this Q meter circuit once. Please note down this Q meter circuit. Have you noted the diagram? Please note down. Noted? ఏమైంది ఏం వారం వర్షం పడతాను. So if you see the circuit, what we are going to do first, we are applying certain frequency. We don't know what is that frequency. We are applying certain frequency, and whatever the voltage is going, but this frequency must be the radio frequency. Remember this point. This frequency is a radio frequency. This frequency should be in the range of radio frequency. So at this particular frequency, what is going to happen now? At a particular frequency, what is going to happen now here? This particular value, whatever the voltage that we are getting across this shunt resistor, so that voltage we can capable of reading by using certain voltmeter, thermocouple voltmeter. There is a link here. Why thermocouple voltmeter? Because we are using the high frequency. Why you are not using the PMMC, you are not using the moving iron, you are not using any other dynamometer also. The dynamometer is also having a frequency limitation. It cannot go beyond certain hertz, because certain kilohertz. But whereas this thermocouple voltmeter is suitable for the high frequency measurement. That is advantage. After the invention of this transducer, all the transducers are suitable for the high frequency applications. Okay, so thermocouple is best suitable for the high frequency voltage measurements. So this high frequency voltage we are taking here, this is the voltage we are taking here. Okay, this is our why we are taking a confirmation. We are taking a confirmation that this is applied voltage. Okay, so this is our confirmation, this is applied voltage. And now our test coil, this is our test coil. So our test coil is having some inductance and resistance. Actually capacitance is not visible, but internally there is a capacitance also. When you take these turns like this, so parasitic capacitance will be there. Whenever current passes here, current is entering and current is leaving, current is entering and current is leaving, current is entering and current is leaving. So definitely what happens now, at this particular edges there is a possibility of capacitance. At this particular edges there is a possibility of capacitance. Okay, this particular edge, there is a possibility of capacitance. This capacitance is called as distributed capacitance. What we call this as? We call it as distributed capacitance. Distributed capacitance, which is constant always. It is constant. Okay, just like inductance of a coil, this distributed capacitance is also constant. So this only we have to measure. Another thing is we are keeping one tuning capacitor. By varying this capacitor, I can measure the voltage across this. So this voltmeter is called as electrostatic voltmeter. What we call this as? We call this as electrostatic voltmeter. So one interesting thing in the Q meter is two voltmeters we are using. One is a thermocouple voltmeter, other one is the electrostatic voltmeter. So two voltmeters we are using. One is a thermocouple voltmeter, other one is the electrostatic voltmeter. Is it clear? Okay, so abhi kya hai na, you just go on adjusting this C. First particular frequency you fix FR, and at that particular frequency definitely this voltage will be something. Now you go on adjusting this capacitor at a particular value of this capacitance. What happens? The voltage across a capacitor will be maximum. So this EC will be maximum. Then once you get the maximum, you lock it. So take that reading and then you can take this formula. Voltage across the capacitor will be maximum if and only if there is a Q times of E. So already this you are getting from the electrostatic voltmeter, and this is already available thermocouple voltmeter. So now Q you can get directly. Q is equal to EC by E. This is one of the important technique, my dear students. So this is the first measurement we are going to measure the Q. But here, my dear students, practically speaking, आपको क्या होना चाहिए? Q is nothing but omega L by R होना चाहिए. R Q is nothing but 1 by omega CR होना चाहिए. Here, what is this C and what is this R and what is this R? This R should be only the coils parameter, but आपको इधर एक shunt resistance series में आ रहा है. Okay, similarly अगर आपको distributed capacitance भी series में आ रहा है. Okay, so इसके लिए आपको एक error होने की chances है. So the true value is this omega L by R. So उसको error कैसा निकालना है? So I will tell you the error methodology. So Q true value is this. Q true value is this omega L by R, but the measurement value क्या होता है? Measurement value क्या होता है? This R से RSH भी आएगा. So this is one error होने की chances है. Okay. Similarly, Q true value क्या है? Q true value is 1 by omega CR, which is the distributed capacitance. Okay. But if you see the measurement value, in addition to this distributed capacitance, we are having a tuning capacitance, that is C to R. Okay, so please note down these values. Things. Is it clear, my dear? Why? Because in addition to distributed capacitance, we are getting the C. This is one technique. There is a possibility of error. Okay, and the second thing is measurement of inductance. आपको पता है resonant frequency FR is equal to 1 by 2 pi root LC. तो एक बार आपको ये resonant frequency find out करने के बाद inductance find out करना easy है. तो inductance भी आप measurement कर सकते हैं. Okay, next effective resistance भी measurement कर सकते हैं. Q is equal to omega L by R. From that we can also find out the resistance. Next measurement of self capacitance. This is most important. The self capacitance को हम distributed capacitance भी बोलते हैं. Distributed capacitance भी बोलते हैं. Okay, distributed capacitance भी बोलते हैं. Noted? This is a distributed capacitance. Okay, So first we have to take a resonant frequency, achieve the resonant frequency. How to confirm it the resonant frequency? Adjust the capacitor value so that you will get the maximum capacitance. So resonant frequency 1 is equal to 1 by 2 pi root over LC. So you are tuning a capacitor C1. This is our unknown parameter. Then change the frequency such a way the second frequency is a 2 times of the first frequency. 2 times of the first frequency. So F2 is equal to 1 by 2 pi root over. So this is again you are going to achieve by changing the tuning. But try to understand. I will explain in this way. So first you fix a resonant frequency, adjust this capacitance and achieve the maximum capacitance. Then apply the formula. Fr is equal to 1 by 2 pi root LC. This C plus this C. Now changing this resonant frequency to higher domains such a way it should have some numerical relationship with the previous one. Once you change now, this resonance is going to be disturbed. This resonance is going to be disturbed. Adjust this tuning capacitor to the other value so that at a new value again you are going to achieve the resonance. Note down that. Now ये दोनों के बीच मौसम चेंज हो गया, हेल्थ भी खराब हो रहा है. So FR2 is equal to 2 times of FR1. If you simplify this, you are going to get the distributed capacitance relation. That's it. So these are the major parameters that we can measure. Okay. Now let us go for some questions. Yeah, try to answer this question. IIT Kharagpur का question है. This CRO का question है. Try to answer this. As I told you, you can take two methods. Fy by Fx. If you take horizontal methods. If you take the horizontal methods, 1 plus half, 1 plus half. So 1 plus half plus 1 plus divided by vertical 1 plus half plus half. So it will be 3 by 2. Or if you take intersections points, that will be very easy. 1, 2, 3 and 2. Simple. 1, 2, 3. So in both the ways 3 by 2. So he's asking Fx by Fy. He's asking Fx by Fy. So the answer will be 2 by 3. Option C is the right answer. Let's go for the next question. What is the answer for this? 𝐂𝐚𝐴 सहानी प्रिपेयर करो भैया. 𝐂𝐚𝐴 सहानी. JD Gupta. JD Gupta backside textbooks, backside questions also 5 minutes. JD Gupta backside also we are having questions. You can prepare for that also. Okay. A certain oscilloscope with 4 cm screen has its own sweep output fed to its input. If the X and Y sensitivities are same, see sensitivity of Y means volts per division. Sensitivity of X means time per division, seconds per division. So this is seconds per division, this is volts per division. So if you take now, these are 4 by 4, the 4 centimeters, these are 4 centimeters. So what he's telling, he's applied the same signal. So if you apply the same signal to the one, two, three, four, 1. Okay. So now this is a scenario. A certain oscilloscope with 4 cm has its own sweep output fed to its input. So that means sensitivity along the time per division, and both the signals are same. So we are going to get the straight line, diagonal line we are going to get. Okay, so let us go for the next question. That's it, my dear. Enough for today. Ganesh.